Start with some number. Fifth question, first part, exercise 6.7. Fifth question, first part. Fifth question, first part. Now let us start it. Fifth question, first part. Now the question is 2nC2 upon nC3 equals to 33 upon 10. Right, students, we want to find the value of n. Now 2nC2 by the formula of NCR, this is equal to 2n factorial upon 2 factorial into n minus r factorial, because NCR equal to n factorial upon r factorial into n minus r factorial. So by using this formula, we can write 2nC2 equals to 2n factorial upon 2 factorial into 2n minus 2 factorial upon n factorial upon 3 factorial into n minus 3 factorial equals to 33 upon 10. Now simplifying it, we can write it like this: 2n minus 2 factorial, and we can write this term in the numerator, 3 factorial n minus 3 factorial upon n factorial equals to 33 upon 10. Right? Now writing 2n factorial as 2n minus 1 and 2n minus 2 factorial, 2 factorial and 2n minus 2 factorial. Writing 3 factorial as 3 into 2 factorial, n minus 3 factorial, and writing, because here we have n minus 3 factorial and in the denominator we have n factorial, so the larger number is n, so we open n factorial, n minus 1, n minus 2 into n minus 3 factorial equal to 33 by 10. And here also 2n is larger than 2n minus 2, so we will open 2n factorial. Now cancel these two, cancel these two, cancel these two, right, and cancel n with n also. So we are left with 2 into 2n minus 1 into 3 upon n minus 1 into n minus 2 equal to 33 upon 10. Now cancel 33 by 3, we get 11 over here. Now solving it further, so we get 4n minus 2 equals to 11 times of n square minus 3n plus 2. So we get 4n minus 2 equal to 11n square minus 33n plus 22. So we get 11n square minus of 37n plus students, here we get 10. Make a correction, right? So we get make a correction that here we have 10, and when we do the cross multiply, so we will write 10 times of 4n minus 2 equal to 11 times of this. So we get 40n minus 20 equal to 11n square minus 33n plus 22, and we get 11n square minus 73n plus 42 equal to 0. n square. Now making factors. The factors will be 66n minus 7n plus 42 equal to 0. Now taking common 11n, we get n minus 6 minus 7, n minus 6 equal to 0. So we get n minus 6, 11n minus 7 equal to 0. So we get n equal to 6 and n equal to 7 by 11. So students, the answer is n equal to 6, rejecting n equal to 7 by 11. So this is the solution of this question, students. Now fifth question, second part. Question is now 11c 2r equal to 11c r plus 5. 11c 2r equals to 11c r plus 5. Now students, I told you the formula that if nca is equal to ncb, then we have either a equal to b or a plus b equal to n. Now students, we shall use this formula over here. So here we can write 2r equals to r plus 5. This is a and this is b. Either 2r equal to r plus 5 or a plus b equal to n, means 2r plus r plus 5 equal to 11. So we get r equal to 5, or 3r equal to 6, we get r equal to 2. So we are getting r equal to 5 or r equal to 2. Now let us start with sixth question, first part. N plus 1 CR plus 1 is to NCR is to N plus 1, N minus 1 CR minus 1 is equal to 11 is to 6 is to 3. Find out N and R. Now students, we can write it like this, that N plus 1 CR plus 1 upon NCR equal to 11 by 6. Taking first two, so we can write n plus 1 CR plus 1 upon NCR equal to 11 upon 6, and then taking second and third, NCR upon n minus 1 CR minus 1 equal to 6 by 3. Now use the formula of NCR, n plus 1 factorial, R plus 1 factorial, and then n minus R. We get n minus 1 factorial over n factorial upon r factorial into n minus r factorial equal to 11 by 6, and here n factorial upon r factorial into n minus r factorial, n minus 1 factorial, r minus 1 factorial, and when we subtract, we can write equal to 2. N plus 1 factorial, n minus r factorial, r factorial, n minus r factorial upon n factorial equal to 11 by 6. Now solving it, cancelling these two. Now here we have n plus 1 and here we have n. So solving n plus 1 factorial, we can write n plus 1 into n factorial into r factorial, and we can write r plus 1 as r plus 1 into r factorial into n factorial 11 by 6. Now cancelling these two and cancelling these two, so we get n plus 1 upon r plus 1 is equal to 11 upon 6, right? Now solving it, 6n plus 6 equal to 11 r plus 6, or we get 6n minus 11 r equal to 0. This is the first equation, right? Now here n factorial upon r factorial into n minus r factorial, r minus 1 factorial into n minus r factorial upon n minus 1 factorial equal to 2, right? Now cancelling n minus r with n minus r, now we can write n factorial as n into n minus 1 factorial, and writing r factorial as r into r minus 1 factorial, like this. इक्वल टू 2, ये कैंसिल हो जाएगा और ये कैंसिल, so we can write n upon r equal to 2, or we get n equals to 2r. Now students, we have two equations. This is number 2. Now solving 1 and 2. So from 1 and 2, putting n equal to 2r over here, we have 6n minus 11r equal to 0. Putting n equal to 2r, students, here we have, please make a correction, 11r plus 11. So we get 11 minus 6 equal to 5. So this is number 1. Now here we have 5. So we get 12r minus 11r equal to 5. So we get r equal to 5. Now putting r equal to 5 over here, so we get n equal to 10. So students, this is the answer. Now students, let us start with this second part. Sixth question. Second part is n minus 1 CR is to NCR is to n plus 1 CR is equals to 6 is to 9 is to 13. Find out n and r. So first of all, we can write n minus 1 CR upon NCR equal to 6 by 9, and here we can upon n plus 1 CR equal to 9 upon 13, right? Now solving it by using the formula, we can write it n minus 1 factorial upon r factorial n minus r minus 1 factorial by using the formula of NCR, and we can write NCR as n factorial upon r factorial into n minus r factorial, and on solving 6 by 9, on writing in lowest terms, we get 2 by 3. Now we can write like this: n minus 1 factorial upon r factorial n minus r minus 1 factorial into r factorial n minus r factorial upon n factorial equals to 2 by 3. Now cancelling r with r now, right? Then here we have n minus 1 and here we have n, and here we have n minus r and n minus r minus 1. So the number which is greater, उसको हमने solve करना है. So n minus r is greater than n minus r minus 1. So we solve n minus r, and we can write n minus r factorial as n minus r into n minus r minus 1 factorial, n minus r minus 1 factorial as it is, and write n factorial as n into n minus 1 factorial equal to 2 by 3. Now cancel n minus 1 with n minus 1, and cancelling n minus r minus 1 with n minus r minus 1. So we get n minus r upon n equals to 6 equals to 2 by 3, right? So on solving it, we get 3n minus 3r equals to 2n, or n minus 3r equal to 0. Now this side, so on solving it in the same way, n factorial upon r factorial n minus r factorial upon n plus 1 factorial upon r factorial n minus r plus 1 factorial equals to 9 by 13. Now simplifying it, n factorial r factorial n minus r factorial n minus r plus 1 factorial upon n plus 1 factorial equals to 9 by 13. Cancel r with r. Now here we have n plus 1 and here we have n, and here we have n minus r plus 1 and n minus r. So n minus r plus 1 is greater. We can write it like this: n minus r plus 1 into n minus r factorial, then n minus r factorial, n plus 1 into n factorial equals to 9 by 13. Cancelling n minus r with n minus r, cancelling n with n. So we get n minus r plus 1 upon n plus 1 equal to 9 by 13. Now solving it, 13n minus 13r plus 13 equal to 9n plus 9. So on solving we get 4n minus 13r equal to minus 4. Right, this is number 2 and this is number 1. Now here n minus 3r equal to 0, so we get n equal to 3r. So putting n equal to 3r over here, so we get 4 into 3r minus 13r equal to minus 4. We get minus r equal to minus 4, and we get r equal to 4. And if r equal to 4, then n will be 3 into 4, n will be 12. Right, students? If n r equal to 4, then n will be 12. Now the question is 4p2 equals to n times of 4c2. Then find the value of n. Sum number 7. Now let us solve it. 4p2, we know the formula of npr. This is equal to 4 factorial upon 4 minus 2 factorial, n times of 4 factorial upon r factorial into n minus r factorial. So we get 4 factorial upon 2 factorial, n times of 4 factorial into 2 into 2. Right, now cancelling 4 with 4, so we get 1 upon 2 equals to n upon 4. So we get n equal to 2. So students, the answer is n equal to 2. And similarly, the second part, npr equals to 1320 and ncr equals to 220. So find the value of n and r. npr, again, npr is n factorial upon n minus r factorial is equal to 1320 n factorial upon r factorial, n minus r factorial equals to 220. Now students, here I am writing it like this: 1 upon r factorial into n factorial upon n minus r factorial equals to 220. Now the value of n factorial upon n minus r factorial, this is equal to 1320 equals to 220. So we get 1320 equals to 220 r factorial, and we get r factorial equal to 1320 upon 220. This is equal to 6, and we know 6 is equal to 3 factorial. So r is equal to 3. Right, students? R equal to 3, and if r equal to 3, then we can find the value of n. So putting the value of r over here, what we get? N factorial n minus 3 factorial is equal to 1320. Right, Now writing n factorial as n minus 1, n minus 2, n minus 3 factorial upon n minus 3 factorial is equal to 1320. Cancelling n minus 3 with n minus 3, so we get n minus 1, n minus 2 equal to 1320. Now writing 1320 as a product of three consecutive numbers, so we can write 12 into 11 into 10. These are the consecutive numbers in descending order. Now we can compare either n with 12 or n minus 1 with 11 और n minus 2 with 10. किसी एक को हमने कंपेयर करना है, तो हमारे पास n कितना आएगा 12. अगर मैं n को इससे कंपेयर करता हूँ 12 के साथ, n is 12. अगर हम n minus 1 को कंपेयर करते हैं 11 के साथ, तो हमारे पास n कितना आएगा 12. और if I compare n minus 2 with 10, तो हमारे पास n कितना आएगा 12. सो हमें कोई किसी एक को कंपेयर करना है. इन ऑल द केसेस n will be same, so we get n equal to 12. Now sum number 8, npr equals to npr plus 1 and ncr equal to ncr minus 1. Find the value of n and r. Now npr, this is equal to n factorial upon n minus r factorial, n factorial upon n minus r minus 1 factorial, and here n factorial upon r factorial, n minus r factorial, n factorial, r minus 1 factorial, n minus r plus 1 factorial. Now students, let us solve it. Now let us solve. Cancelling, first I solve writing n minus r as n minus r, n minus r minus 1 factorial is equal to n factorial upon n minus r minus 1 factorial. Cancelling these two and cancelling these two, we get 1 upon n minus r equal to 1, or we get n minus r equal to 1. This is the first equation. And similarly over here, cancelling n factorial with n factorial, so we get 1 upon r into r minus 1 factorial, n minus r factorial, 1 upon r minus 1 factorial, n minus r plus 1, and n minus r factorial, like this. Now cancelling r minus 1 with r minus 1, cancelling n minus r with n minus r, so what we get, 1 upon r equals to 1 upon n minus r plus 1. So n minus r plus 1 equal to r, n minus 2r equal to minus 1. So this is our second equation. N minus r equal to 1, n minus 2r equal to minus 1. Now solving it, so we get r equal to 2. Now n minus r equal to 1, n minus 2 equal to 1, we get n equal to 3. So r equal to 2 and n equal to 3. Now ninth question, we have to prove that r into ncr is equal to n times of n minus 1 c r minus 1. Now students, we can write it like this: ncr upon n minus 1 c r minus 1 equal to n by r. We can write this question like this. Now we shall prove that ncr upon n minus 1 c r minus 1 equal to n by r. So ncr, n factorial upon r factorial into n minus r factorial, taking left side, then n minus 1 factorial upon r minus 1 factorial into n minus r. हमने n-1 में से इसको माइनस करना है, तो हमारे पास कितना आता है n-r, राइट। नाउ solving it, n factorial upon r factorial into n minus r factorial, r minus 1 factorial, n minus r factorial upon n minus 1 factorial. So cancelling n minus r with n minus r. Now writing n as n into n minus 1 factorial and r as r into r minus 1 factorial, r minus 1 factorial and n minus 1 factorial. So cancelling r minus 1 with r minus 1, n minus 1 with n minus 1. So we get n upon r, which is equal to right side. Now let us start with the question number 9th, second part. Question is we have to prove that NCR plus 2 times of NCR minus 1 plus NCR minus 2 equals to n plus 2 CR. Now let us do. So take left side first. We can write NCR. Now here we have 2. So we can write it like this: NCR minus 1 plus NCR minus 1 plus NCR minus 2. Now NCR plus NCR minus 1. Now students, I have told you the property that NCR plus NCR plus 1. I have told you the property last time in the previous video. NCR plus NCR minus 1. This is equal to n plus 1 CR. ये जो n होता है इसमें हमारा एक ऐड हो जाएगा, r और r minus 1 में द नंबर विच इज ग्रेटर वो हम यहाँ लिखते हैं. नाउ NCR plus NCR minus 1, this is equal to n plus 1 CR. n में हमें एक ऐड करना है, r और r minus 1 में जो ग्रेटर होगा उसको लिखते हैं. नाउ अप्लाइंग द सेम प्रॉपर्टी ओवर हियर. यहाँ n है हमारे पास, so we write n plus 1 C. The number r minus 1 and r minus 2. r minus 1 is greater. So we write n plus 1 C r minus 1. Now n plus 1. Now applying the same property, we can write n plus 2 C. Now the number r and r minus 1. r is greater. So we can write n plus 2 CR. So which is equal to right side. So students, hence proved. Now let us do the next question, number 10. Now the 10th question is that if r is more than equal to 1 less than equal to n, then prove that n into n minus 1 C r minus 1 is equal to n minus r plus 1 into n C r minus 1. So let us do this. Now we can write this expression like this, that n minus 1 C r minus 1 upon n C r minus 1 is equal to n minus r plus 1 upon n. Now take left side. Now let us use the formula. Formula is n minus 1 factorial upon r minus 1 factorial, then n minus 1 minus r plus 1, we get n minus r factorial. Now upon n factorial, then r minus 1 factorial into n minus r plus 1 factorial. Now solving it further, n minus 1 factorial upon r minus 1 factorial, n minus r factorial, and over here r minus 1 factorial, n minus r plus 1 factorial upon n factorial, right? Now cancelling r minus 1 with r minus 1, so n minus 1 factorial. Now writing n minus r plus 1 as n minus r plus 1 into n minus r plus 1 upon n minus r factorial, and writing n as n into n minus 1 factorial, cancelling these two and cancelling n minus r with n minus r, so we get n minus r plus 1 upon n. So students, this is the solution. Now 11th question is prove that 2n is equal to 2 power n into 1 3 into 5 up to 2n minus 1 upon n factorial. So students, here in this question we take right side, and right side is 2 power n 1 into 3 into 5 up to 2n minus 1 n factorial. Now students, here multiply and divide with 2 4 6 up to 2n, multiply and divide by 2 into 4 into 6 up to 2n, like this. Now students, these are the odd numbers and these are the even numbers, so we combine them. So we write like this: 1 into 3 2 into 3 into 4 up to 2n, then upon n factorial. Now here we have 2 into 4 into 6 up to n terms, so taking 2 common, we get 2 power n 1 into 2 into 3 up to n, like this. Students, you can see here these are the n factors and these are also n factors, so total we have 2 n factors. So we write 1 2 3 into 4 up to 2n. Now cancel 2n, 2 power n with 2 power n, 1 2 3 into 4 up to 2n, this can be written as 2n factorial, then n factorial, 1 into 2 into 3 up to n, again this can be written as 2n factorial. I tell you students, if we have 1 into 2 into 3 into 4, इसको हम लिख सकते हैं इस तरीके से 4 into 3 into 2 into 1, so this is equal to 4 factorial, right? So therefore 1 into 2 into 3 into 4 up to 2n can be written as 2n factorial, and 1 into 2 into 3 up to n can be written as n factorial. Now if I take left side, so left side is 2ncn, and this is equal to 2n factorial upon n factorial into n minus r factorial, 2n minus n factorial. So we get 2n factorial upon n factorial into n factorial. So left side equal to right side, so hence proved. Right students, I hope this is clear to you.